Hello everybody and welcome back to Learning and Understanding Blueprint. Quick aside, I know it's been a minute since I've uploaded a video. I have severe ADHD and there is a medicine shortage. I don't have my medicine. I'm trying my best. Please bear with me. Last episode, we started talking about variables, specifically Booleans, and how they can affect the flow of your code and your game's logic. Today, we're going to be talking about integers and floats. An integer, as you can see, is like 1, 2, and 3, but so are floats. They're also 1, 2, and 3, except floats can also have decimals? Well, yeah. So integers have to be whole numbers. They're not allowed to have decimal places, whereas floats are. However, you might be thinking, why would I ever use an integer whenever the float is more flexible? It has more range. Also, ignore this creepy guy down here at the bottom. Unfortunately, when we get into integers and floats, he has to rear his head into things. But anyway, why use an integer whenever we can just use a float? Well, there's actually two major reasons. One is that sometimes your code just needs a whole number. So to have a float potentially have a decimal place because of either somewhere where you miscoded or it behaves in a way that you don't expect it to, then your code receives a float with a decimal and now it's on fire. So by making it an integer, we're guaranteeing that it's going to be a whole number. The other reason for an indie developer isn't quite as important, but it's still good to know and to keep in mind. And that is that integers take up less memory than floats. The smallest float takes up 4 bits, whereas the smallest integer only takes up 2. Now, the bigger the number, the more either of them take up. However, floats consistently take up more and more and more quicker than integers do. Let me give you an example. An integer being the smallest at 2 bytes and a float being the smallest at 4 bytes doesn't really mean a lot to those that aren't tech savvy. So let's take 16 gigs of RAM. 16 gigs is pretty average nowadays. In 16 gigs of RAM, there is 128 billion bits. If this was Twitch, that'd be like $5. No ads, earlier content, ask me questions, and even get a Discord call with me to help with your game. These are all on my Patreon right now. A float taking 4 of those bits and an integer only taking 2 isn't that huge whenever you're talking about a small indie project. However, when you look at something that's giant like a AAA game like Overwatch, it uses down to the last bit of memory that it can use on a console to be able to perform the way that it does. So as a small indie dev, remember, anytime you can get away with using an integer, that whole number, instead of a float, use the integer. It's just a better practice and safer for your code. Now let's look at an example that I've set up so we can further learn how to use integers to affect our game as well as the logic flow of our code. In this example, you'll see that I've set up 3 doors, one with a whole number or integer above each one, 1, 2, and 3. On the left-hand side, we have a screen and a button. On the screen, you can see that we have the number 1. So with the number 1 selected, I can then go over here and press the button, and you'll note that door number 1 opens. If I wanted to, I could then change the screen to display 3 instead, hit the button, and you'll note door 3 opens. Or if I leave it on 3, I can hit the button again, and door number 3 will close. I don't want to get too into exactly how this is made, as it's a bit too technical for what we are learning today, but let's go ahead and look at this piece by piece. Remember, we're not going to learn how to do this exactly, but we can still look at the code and see how the integers are being used. You'll notice on this is the BP for the screen. So for this thing right here, we have a custom event that I created called change door. Now, let's take a look at what the code is doing. We have a variable. You'll note that it's this teal color. That means that on the left-hand side, if you check, it is an integer. So it's comparing the current door integer with the max door integer. And since we're comparing using math, we get a Boolean, which as you remember means true or false. So we're saying, hey, is the current door greater than or equal to the max amount of doors? Because if it is, then we need to reset the cycle. Go ahead and take the current door back down to 0, and then run the code that changes the text on screen. If our current door is not greater than or equal to the max door, which we would get a false, then set the current door to current door plus 1. Some of the more observant among you may notice something. There is no door 0. If we go back, I can even show you. Let's hit play. There's door 1, 2, and 3. And in fact, door 0 never appears on screen. So what's happening here? Why is it that we're setting the current door to 0 whenever we're resetting the cycle, yet we only have a 1 on this door and a 1 on screen? Do you remember this guy from earlier? Mr. Array? Well, he's coming out of his cave. So why am I making arrays come off as scary or the bad guy? Arrays are actually amazing. They help us do incredible things, but for beginners, they're quite confusing, and I can understand why. For now, just remember that an array is a list. A list of what? Literally anything. You can have an array of actors, an array of blueprints, an array of static meshes, an array of booleans. Anything you can think of, you can make an array of. In fact, you can have an array of arrays. That's right, you can have a list of lists. But here comes the confusing part, the thing that makes every new person's brain melt just a little bit. The first item of an array is in position 0. The second item is in position 1. The third item is in position 2. Don't ask, I didn't design arrays. So when we're setting the current door back down to 0, it's because we're dealing with an array of doors. So current door being 0 is actually the first door. However, let's look at that a little bit closer. Now we're inside BP button. This is the blueprint for the button. You'll see that we have a custom event here called send signal. And what it does is it gets an array of actors. As you can see, the array is ... It's a little grid of 9 dots. It's indicating an array. So we have an array of actors. We have the screen and the current door. So we go into our array of actors, which in this case is our 3 doors. Each of these is an actor. We grab the current door, and remember, since it's an array, it's -1. So if we wanted the third door, it would be 2. We pull it out of the array of actors, and something you remember from previous episodes, we send an interface or a message that the button has been pressed. Then the door, which we are now in the BP door, acts accordingly to whatever happens whenever it receives the message that the button was pressed. So in this case, it toggles door. Now this door doesn't know that it's 1, 2, or 3. The only thing that matters is that the button knows which door to send it to. And in this case it does, because the button has an array of actors that are the doors. The screen controls which one is the current door. It takes the current door from the array of actors and sends the button pressed message to the door. Again, don't worry too much about the specifics of the code. We're more or less just wanting to talk about integers and their roles in coding and the flow of logic. However, let's move on to floats. So something that you probably see floats in a lot is money. Well, I've created a little store system here. You can see that when I hit this button, the store pops up. We have a potion for $1.25 and we have $2.53. Now, a lot of games will just not use floats for money to save memory. Have you ever noticed that when you receive gold, you tend to get 55 gold, not 55.2 gold? Or in some cases, like World of Warcraft, you might get silver or copper. You very rarely actually get this decimal point. And it's to save space because these are huge AAA games. But some of us like to use actual money values, such as $1.25, in which case we would use floats. So right now I have 253 and it's $1.25, which means I should be able to purchase one. I'll click on the button and you'll note we successfully purchased a potion and now we have $1.28. If I click the button again, we'll drop down to 3 cents. And if I try to purchase a third, it's not going to let us because we don't have enough money. So I can then hit the back button and return to the game. So let's go ahead and take a look at how floats are being used in our code to do something like that store system. So this is taking place in the BP first person character. He has a function on the left hand side, which I haven't taught you about yet, but don't worry, think of it as a special custom event. Do you remember whenever we made the interface We could have a return value. We could send a message and then they would send something back. A function is sort of like that. It's like a custom event that can return information. Regardless, let's take a look at the code. So when we call this function, you'll see that it requires that we input an amount. We take our current money and add the amount to it. Now, you might be wondering, well, wait a minute. Didn't you purchase something which would subtract the amount? Well, that is actually why we take the current money and add the amount to it. Because in math, if we were to add a negative number, it would actually subtract it. For example, 3 plus -1 is 2. So whenever we call this, instead of having two separate functions, one for adding and one for subtracting, we simply add the amount to our current money, so therefore it can service as both. So after we add the amount to our current money, I then set a variable that I'm calling current money temp. This is a safety net to make sure that we're not spending money that we don't have. Let me show you. After we set current money temp, you'll see that we have a branch. The condition is to make sure that current money temp isn't less than 0. Because you'll see here, if current money temp is less than 0, then we're gonna play an error noise and we're gonna make sure that we set successful to false and return that success was false. Because remember, current money temp is current money plus the amount, which could be a negative number. Meaning, if current money temp is less than 0, we didn't have enough money, so we're gonna make sure that this is not successful. However, if current money temp isn't less than 0, then what we're going to do is we're going to take the temporary variable, set it to the regular current money variable, let it know that it was a success, and return that it was indeed a success. This video was a little dense, a little bit heavier than normal, and there was a lot of code that we didn't really pay attention to in order to make sure that we focused on integers and floats, and you got your first taste of arrays. If you have questions, please let me know in the comments. Like, comment, and subscribe, and remember, I have severe ADHD, there's a medicine shortage. I will get videos out as soon as I can, bear with me. Thanks so much for watching, and I'll see you in the next one.